today we will discuss this exercise, which is exercise 10.21. Okay, page 179 from this book. Okay, static made simple. I will not draw the original figure here. The question, I will just go directly to draw the free body diagram. Okay, so you might want to clear on this figure. Okay, you can come back to this figure later on to see what is there. So you can see that at O there is a bearing, D there is a ball and socket joint, and cable at A. Okay, so that is for the figure. Okay, so the question said, the bend rod shown in the figure is supported by a radial bearing at O. So here O is a radial bearing. So please go and check your table for reaction at radial bearing. Okay, radial bearing. And then at a ball and socket joint at D, which is here, ball and socket joint, and cable at AE. So we have a cable from A to E. A 75 kilogram mass is attached to point C. So you are required to find the tension at cable AE, this one, and also reaction at O and D. Okay, so first thing, we need to draw the free body diagram. Okay, so our free body diagram, we will start as normal, drawing if the component said something about the mass of the component. Here we have the component O2, this is B. So component OBD, this component OBD, nothing stated about the mass of this component itself, so you can ignore the mass of this component. If there is a mass, you have to put mg downward at the center of gravity of component. Okay, and then we go to the external forces, including cable, if there are any external forces. In this case, we have two external forces which held by a cable, which is from A to E, AE, and the other one is at C. So the first one, AE, this is from AE, so we have one forces here, which I call it as TAE. Okay, the cable must always upward of the component. We consider always it is in tension for the cable. And then we have a mass 75 kilogram supported by a cable, so also going downward straight. This is call it as TAE, we call it as TC, for example, or FC, force at point C, which is, we know here it is equal to M70, call it as mg. Okay, equal to mg, FC. Then finish for the external forces. We should go to the reaction force now. So the reaction force that we have here, we have two parts support this component. The first one is O, the second one is D. Okay, so at O, said that it is a radial bearing. Okay, so radial bearing, it is positioned this way, meaning that it will allow the rotation in Z axis. Okay, allow the rotation in Z axis, and it is a radial bearing. The radial is in Z axis, so it also will allow the movement in Z axis. Please refer to the table for the reaction force if you're not convenient with the reaction force. Okay, so this we have in Z axis, the bearing is drawing this direction, so there's no force hanging or pushing from Z direction, so it's no force, but the bearing hold the component from moving X and Y direction. So there will be this one, O, X, O, Y. Okay, so there will be OX and OY. There's no on Z direction, and in the figure of the table of the reaction, you see that there is possibility to have a moment in y and x direction. But as I said, if there is nothing stated for the moment, you will not consider any moment. So there will be no moment for y and x direction. If the question said there will be supported the moment, okay, so you have to put moment on y and also the x. On z there will be no moment because the use of the bearing is to allow the rotation in z direction in this case. Okay, so only two unknown on y, which is oy and ox. And then we go to the ball and socket joint. You know that it is allow the movement for all rotation, so there will be no moment, but it fixes the component from moving x, y and z. So there will be dx, dy, dz. Okay, dx, dy and dz. By doing that, you see that you have 1, 2, 3, 4, 5 and 6 unknown in this case. TA, E is not known also, so you have 1, 2, 3, 4, 5, 6 unknown. Okay, so now you have 6 unknown. Okay, 6 unknown, you will use 6 equation, 3 from forces and 3 from moment. So sigma fx, fy, fz, 3 equation. Sigma moment x, y and z, another 3 equations. So you have 6 equations to solve 6 unknown. You can solve this problem. Okay, so the first step here, I'm done with the first step, which is to draw the F, B, D. This is your first step. Okay, second step, you go, because you want to have the equation in term of force, Fx, Fy and Fj. So you have to solve the component of force. Solving step 2, solving component of force. Okay, so you want to solve the component of force, meaning that you want to put all these forces in terms of I, J and K. So we go one by one. We have the first one, F. Let's say this is the simplest one. So 1, Fc, you transform in terms of I, J, K. So X will be 0, Z will be 0 only in Y. So it is equal to negative, so you calculate this one, equal to the M75 times 9.81. So you have here FC, you will have FC. From my calculation, FC will go 735.75 Newton J. Okay, because it is on Y direction. And going downward will be negative. Okay, it is actually a 1D force in 3D plane. Okay, there's no on X and on Z, only on Y direction. And then we go to the second, which is TAE. Okay, looking from this one, you can use the coordinate method. Okay, which is we have to have dx, dy and dz. Dx moving from here to back 0.3, so negative 0.3. dy going upward 0.6, positive 0.6. dz from here going this way, positive also 0.2. From here you calculate d equal to this one, squared plus 0.6 squared plus 0.2 squared. So you have the d. I've calculated that one so that I don't have to spend a lot of time here. So d is 0.7 meter. So from here you have TAE. You want to transform actually everything in terms of IJK. So TAE equal to TAE dx divided by d I plus TAE dy divided by dj plus TAE dz divided by dk. Okay, so that's one for TAE, and then you will have the TAE is equal to negative 0.428 TAEI plus 0.857 TAEJ plus 0.286 TAEK. So you have the second one, which is the TAE. Okay, and then we go to the reaction at number 3. Let's say we go to O. Of the O, this is not 0, this is the O. O, you will have OXI plus OYJ plus 0. That one. So OXI plus OYJ. And at the point D, the first one, we have D equal to dxi plus dyj plus dx. Okay, so now we have all the forces in terms of I, J, and K. Okay, so I want to put all this in terms of table so that I will not miss any forces in I, J, and K direction. If you are good enough, you can directly say you can have add directly from I direction. We have this one plus this one plus this one, the first equation. But if you are not sure with you will miss something, so you can put it in the table first. So I will erase the thing that is not needed here. Okay, so I will have one small table, which is I, J, and K, and this is the force. FC first, TAE, O, and D. Okay, so this one will be 0, negative 735.57, 0. TAE, you know you have negative 0.428 TAE, 0.857 TAE, 0.286 TAE. The O, you will have OX, OY, and this one is 0. The D, you have DX, DY, and DZ. Okay, so by doing that, you are now clear that you will have all this one. Add in I, D will be 0, in Y will be 0, in Z will be 0. So your equation will be minus 0.428 TAE plus OX plus DX equal to 0. This is your first equation. Going to the second one, minus 735.75 plus 0.857 TAE plus 0.286 TAE equal to 0. Your second equation, sorry, minus TAE. So I'm going this way. Okay, plus OY plus DY equal to 0. Your second equation, and then 0.286 TAE plus DZ equal to 0 is your third equation. Okay, now you have 3 equations, but you will still have 1, 2, 3, 4, 5, 6, 6 unknown. So you have 3 equations. You have 6 unknown, you cannot solve, but you will maintain this equation to be used later on when you go to the second part, which is the third part, which is solving component of moment. Here we just solving the component of force, so we have this one. We go to the solving component of moment. Okay. So done for the second part, second step. The third step, I will erase this one. Okay. Third one, solving component of moment. Okay, solving component of moment, you have to analyze first the figure, and normally we will search for the point that have a lot of unknown. The most unknown, we will find that point and we take the moment about that point. Okay, the aim is when we take the moment at the point that have a lot of unknown, we can directly eliminate that unknown in our calculation and leaving us with several unknown that can be solved pretty easily. Okay, so in this case, we have one unknown here, 2 here, and 3 there. So what I'm doing is I will going to have a moment about point D. Okay, so if I'm taking a moment about point D, I will only have 1, 2, 3 unknown. 3 unknown with 3 equations I can solve. But if you go to point O, you eliminate 2 unknown, you still have 3 and 4 unknown. Okay, so that's why it is good. It is important to find the correct point to take the moment. Choose the point that have a lot of unknown. So in this case, we go to point D. Okay, sigma moment at point D equal to. Okay, you know that the moment R cross F and not the opposite direction. So moment is R cross F. Where's my moment? Okay, moment is R cross F, and you want to I J K. That one also right hand. Okay, so moment is R cross F. So you want to have the first one. We want to take moment about point D. So FC first. Okay, FC R cross FC. Okay, so R must be from point where you take the moment. In this case is D. Okay, to any point on this line of action of force. The easiest one, I will put the point C. So RDC. RDC. I think it is easy for you now because you have already done this several times before. Okay, this is the first one. Plus moment of point D because of what? This one. Cross TAE. Okay, so R from D to any point on this line. So the easiest one for us maybe to take the point A plus R from D to point cross, we have X. So from D to any on this line, so it will be easy to have DO plus RD cross OY, also any point along this line of action of force. The easiest one might be point O. Okay, so we go to the first one, RDC cross FC. So R from D to C, which is this one, nothing on X and nothing on Z and Y, it is only negative X direction, so negative 0.7 I cross the value of IJ, which is we have calculated minus 735, and you will do it one by one. So not in only one, I cross J, which is I cross J will become K, so the value is 5, negative will be positive, 15.025 Newton meter K. So I cross J equal to K. And then we go to the RDA cross TAE, which is RDA first. From D to go to A, so you have to go negative X, negative Z, nothing on Y. So minus 1.4 I, because you go this direction. Also negative in Z, which is 0.7, 0.5, 0.2, minus 0.7 K and 0 on Y cross. TAE, we have here the TAE minus 0.428 TAE I plus 0.85 TAEJ plus 0.286 TAE. Okay, I'm not showing you one by one because it will be long way. Okay, but you have already mastered this one. You start by first one, IJ, and we go to the IK, and then later on KI, KJ, and also KK, and you will follow this one. Okay, you do it one by one, or you use the determinant. Okay, whichever method you feel that is easier for you. So at the end, you simplify this one. You will have the, this is as 0.6 TAEI plus 0.7 TAEJ minus 1.2 TAEK. Okay, so you have that, and then we go to the this one and this one. DO OX equal to, from D to O, so you have negative 1.4I. Okay, going this way, negative, also negative in Z, 0.5, 0.2, 0.7, negative 1.4 K. Okay, nothing on Z direction, nothing on Y direction, so cross OX I. Okay, so use this one, I cross I will be 0, K cross I, KI will be J, so your answer will be in J direction, which is minus, and positive will be minus 1.40xj, and then you have RDO cross OY, which is negative 1.4I minus 1.4K cross OYJ. So we have IJ will be K, KI will be J. So your answer is later on will be OY in J and in K. So which is, here we have 1.4 OYI minus 1.4 OYK. Okay, so now you have the moment in terms of I, J and K for the four forces, FC, TAE, OX and OY. Okay, so you have four forces. Four. If you look at it from here, you have four, but you have three unknown actually. So you have to look at one by one. This is OY, OY. Okay, only one unknown. Okay, and then if you look at from this long equation, you might not clear for you how many unknown you have. So we will put everything in terms of table. Okay, in terms of table, you will see that we have clearly which part I, we have how many unknown, J, how many unknown, and K, how many unknown. If you see, you think that you are good enough, you can solve from here. You take directly I direction, plus I equal to 0, J equal to 0, K equal to 0. But I'm urging you to use the table, okay, so that you will not make any mistake or lose any information so in your calculation, and you will lose some marks. Okay, so we will put this one in the table. I've put all the component of this moment into this table, which is we have, this is the source of the moment, which is we have FC, TAE, OX and OY. We have calculated, we come up with the equation. Now I put everything in the table so that we can have clearly the direction of I, J and K. So the first one, we have this, and then when we put together, we have the sum of this will come to 0, in I we come to 0, J we come to 0, K we come to 0. By doing that, I can come up with the equation. This one, 0.6 TAE plus this one equal to 0, the equation number 4, because we already have from the forces, first equation, and then 0.7 TAE minus 1.4, this one equal to 0. We have here 515 minus this one, minus 1.4 equal to 0, equation number 6 from this table. Okay, I'm urging you to use this table even though it is slightly long, but for not doing any mistake or you lose something in any direction I, J and K. Okay, so now we have this table. You can see that we have 3 equations here. Okay, 3 equations, and then we have 3 unknown, which is TAE, and then OX and OY. Okay, we have TAE, OX and OY. 3 equations with 3 unknown. For sure we can solve this one. And looking from this equation 4 and 6, we have TAE and OY. So we have TAE and also OY here. So you can solve first. I'm not going one by one, the solving of it. Okay, so where is my TAE? TAE is this one. So I have solved the TAE. Okay, so if you solve 4 and 6, okay, solving from 4 and 6, you will have the OY equal to negative 368.93 Newton. Okay, this is OY, which is, if we want to translate this, it will become OY is actually 368.93 Newton, and the direction will be downward. Okay, the direction will be downward because from our assumption we have OY which is going upward. Actually we got the negative value, so this one will be 368 going downward. But when you want to replace back this one into equation, let's say you simplify this one and you want to replace back in the equation, you have to use this one, negative, not the positive one. This is our interpretation of what is said when it is negative. Okay, so in our calculation, this is the original value, so you have to put this one again. So I'll put this negative value in equation number 4. Okay, put it in equation number 4, you will have the TAE is equal to 859.61 Newton. Okay, so you have the OY and TAE, So from here you have the value of TAE. Okay, you have the value of TAE. You want to replace this one is equation number 5. Okay, once you replace that in the equation number 5, you will have the OX. Okay, so the first step, you solve from 4 and 6. Okay, maybe you simplify, becoming the OY equal TAE equal to something, and then this TAE is replaced here, and then you get the OY, and then you go back, put this OY here, and then you get the TAE. Now you have the TAE, so you put in this one, you will have TAE is equal to 429.81 Newton. Okay, so the TAE is 429.81 Newton. Okay, positive meaning that same as this one. This one is also the TAE. Oh, sorry. This is OX. 429.81. So OX also positive direction, same as our assumption. So OX positive, TAE of course have to be positive. If you get the tension negative, there is something wrong with your calculation. So go back and check the calculation. But for OX and OY, doesn't matter. If it is negative, it is opposite direction from your assumption. Okay, now from this, you have already solved for 3 unknown, which is OX, OY, and O. OX, TAE, and also OY. Okay. So let me put it here. So now, in your calculation, OY here is negative 368.93, which is going downward. OX 428.81. TAE 859.61. Okay, so now you have 1, 2, 3 more unknown to be solved using equation number 1 and 2. Okay, so I can erase this one. Okay, go back to your equation number 1, 2 and 3. So you have to put, I don't want to show one by one, just put TAE, the one that you have here, OY and also OX in equation 1, 2 and 3. Okay, so I put one by one, equation number 1, 2 and 3. Okay, so and then you have the answer as dz equal to 245.86, and then you will have dx equal to 61.9 and dy equal to 368 Newton. Okay, so it's your calculation. Actually, when you calculate this one, okay, you will have actually the dz, okay, the dz from, okay, so sorry for that one, the dz from your calculation, you will have dz equal to negative, okay, so meaning that in this figure the dz will go this direction, opposite from here, okay, dz equal to 245.86, and then you replace the original value dz equal to negative inside the equation number 1. You will have also the dx equal to negative this one, which means that the dx is also opposite direction by value 61.9 Newton. And lastly, you calculate again, you get the dy, which is directly a positive here, positive, so dy is equal to 368. Okay, you calculate from that one, you get the negative value of x and z, meaning that it is just opposite direction. You will have to use this negative value in your calculation. This is only your interpretation of what happened when it is negative, which is opposite direction. And the whole calculation, you have to stick for the first figure, original figure, you maintain the value as negative, and then you get the answer. Okay, that's all. I'm not showing the step one by one because it will be too long, but you know how to do it, because the one that I'm not showing you is how to calculate the moment exactly point by point. You already mastered that one, and the other one is how to put or solve using simultaneous equation. Either you do it manually like here, or you put it in your calculator. The calculator can also give you the answer. Okay, but I'm stressing here for the interpretation of what happened when the value is negative, meaning that it's just opposite direction from our assumption. Okay, it's not wrong, it is opposite direction. Only one thing, which is the tension, must always positive in your calculation. If you got negative for your tension, either your free body diagram is incorrect or your calculation is wrong. Okay, you have to have always the positive value for the tension. So that's all for this chapter, which is equilibrium 3 dimension for the rigid body. Okay, so see you in the next chapter.